Foundations of Amateur Radio. If you've been around radio amateurs for a little while, you're likely to have heard about the solar cycle and that it affects radio propagation for HF, or high frequency, also known as shortwave communications. The frequency is in the range of around 3 to 30 megahertz, or 100 meters to 10 meters wavelength. One of the main ways it's used is for long-distance or global communication, and one of the most common ways that's done is using the ionosphere around the globe to refract a radio signal. In September 2020, the Solar Cycle 25 prediction panel announced that Solar Cycle 25 had commenced in December 2019, and radio amateurs around the globe rejoiced. The first question for me was, why Solar Cycle 25? You might think of the sun as a stable light in the sky. As it happens, the bright light hides all manner of ferocious activity. One of the measures of this activity is the number of dots observed on the surface of our star. These dots are called sunspots. As solar activity increases, the number of sunspots increases. The activity is cyclical. It increases and decreases over time. Each increase and decrease combined is known as a solar cycle. On average, a cycle lasts about 10.7 years. Simple maths gives you that solar cycles started somewhere around 1750. That seems a little strange. Our sun is 4.6 billion years old. There are paintings on the rocks at Ubirr in the Northern Territory of Australia that are 40,000 years old. The pyramids in Egypt are 4,500 years old. The solar cycle has been going for a lot longer than the 7 million years there have been humans on the planet, let alone dinosaurs who experienced the solar cycle 66 million years ago. Using fossil records, we've determined that the solar cycle has been stable for at least the last 700 million years. Chinese astronomers recorded solar activity around 800 BC. And Chinese and Korean astronomers frequently observed sunspots, but no known drawings exist of these observations. The first person to draw sunspots was John of Worcester on the 8th of December 1128. 5 days later, half a world away, in Korea on the 13th of December 1128, the astronomers in Songdo reported a red vapor that, quote, soared and filled the sky, end quote, describing the aurora borealis in the night sky that resulted from those very same sunspots. In the early 1600s, there was plenty of activity around the recording of sunspots. Thomas Harriot appears to have predated Galileo Galilei by more than a year, with notes and drawings dated the 8th of December 1610. There's plenty of other names during this period. Father and son David and Johannes Fabricius, and Christoph Scheiner, to name 3. But I'm moving on. The solar cycle was first described by Christian Horrebow, who more than a century later in 1775 wrote, quote, "It appears that after the course of a certain number of years, the appearance of the sun repeats itself with respect to the number and size of the spots." End quote. Recognition of the solar cycle was awarded to Samuel Heinrich Schwab, who noticed the regular variation in the number of sunspots, and published his findings in a short article entitled Solar Observations During 1843, in which he suggested that the cycle was 10 years. Stay with me, we're getting close to solar cycle number 1. In 1848, Rudolf Wolf devised a way to quantify sunspot activity. His method, named the Wolf number, is still in use today, though we call it the Relative or International Sunspot number. In 1852, he published his findings on all the available data on sunspot activity, going back to 1610, and calculated the average solar cycle duration as 11.11 years. He didn't have enough observations to reliably identify solar cycles before 1755, so the 1755 to 1766 solar cycle is what we now consider solar cycle number 1, lasting 11.3 years with a maximum of 144.1 sunspots in June of 1761. Until 2009, it was thought that there had been 28 solar cycles between 1699 and 2008, with an average duration of 11.04 years. But it appears that the 15-year solar cycle between 1784 and 1799 was actually 2 cycles, making the average length only 10.7 years. I should also point out that there have been solar cycles as short as 8 years and as long as 14 years. With the announcement of Solar Cycle 25 comes improved propagation for anyone who cares to get on air and make noise. The current predictions vary depending on the method used, ranging from a very weak to a moderate Solar Cycle 25. There are predictions for the solar maximum, the time with the most sunspot activity, to occur between 2023 and 2026, with a sunspot range between 95 and 130. By comparison, during the previous solar cycle, in 2011 the first peak hit 99, and the second peak in 2014 hit 101. I have purposely stayed away from electromagnetic fields, geomagnetic impacts, and the actual methods for HF propagation. I'll look at those another time. I can tell you that we've gone a little beyond counting dots on the Sun to determine activity, and we have a whole slew of satellites orbiting our star doing all manner of scientific discovery, all of which helps our understanding of what's going on in the massive physics phenomenon 8 minutes and 20 seconds away by radio. That said, solar eruptions are still pretty unpredictable, much like the weather around us. Not because we don't want to know, but because this is a very complex one to solve. Much like ionospheric propagation is hard to forecast, much easier to measure actual performance, and much more accurate. So, if you want to know how well propagation is going to be today, turn on your radio and have a listen. If you want to know how great it's going to be tomorrow, look at the forecast, but bring an umbrella or an FT8 transmitter. I'm Ono, Victor Kilo 6, Foxtrot Lima, Alpha Bravo.